Now let's start off with decomposition reaction. Now imagine you have a cell phone. A cell phone is a very complex device and it hosts technologies like camera, electronics, telecommunication, and a lot more. But now one fine day you decide that you want to rip your phone apart and separate all the technologies. So you open it up, you remove a camera, put it aside, remove the battery, keep it aside, the internal circuits, you keep them aside. Now what you have actually done is you have broken down a complex technology into simpler technologies. In a similar manner, what we have over here is a decomposition reaction. In a decomposition reaction, you are breaking down a complex substance, which is a reactant, into complex substances, which are your products. The reason we have said substances is because you have multiple products. So you might have two or more than two. There are some examples where you might have 3 to 4 products together. Now, you might find this completely opposite to the combination reaction that we have studied previously. Now yes, it actually is, as in combination you have two simple substances come together, form a complex product, but over here you have a complex reactant which breaks down into simpler products. But one more thing is opposing. The combination reaction was exothermic, while decomposition reaction is endothermic. Now, endothermic means that it requires energy or absorbs energy for the reaction to happen. Now, the reason why this is endothermic is because when you have a breaking of a bond, you need some amount of energy. When something is stable, it does not break easily, and hence you need to supply some kind of energy, which may be in some forms, and make the molecules excite, vibrate with energy, and repel apart. It is as similar as when you're tired and have to go out to play. You eat some food, you get some energy, and then you go out, you play. Now for decomposition reaction, obviously you're not going to give it some food. But what you're going to do is, there are 3 forms of energy which you can supply. One of which is heat. Thermal. So you can supply energy through heat by keeping a burner around it. Or you could use the process of electrolysis. Now, electrolysis means breaking using electricity. Electro over here means electricity, and lysis means breaking, and hence breaking using electricity. The third form of energy that you could give is light. Light is called as photo, and this type is called as photolysis, which means breaking using light. Now let's start off by discussing thermal decomposition. Now, as we have said, thermal decomposition is where you have heat as a form of energy which is used to break down your reactant. A classic example of thermal decomposition would be the breaking down of limestone into quicklime and carbon dioxide. Limestone is calcium carbonate, which is CaCO3. When you subject this to heat may be from anywhere, either a Bunsen burner, a burning flame, or some other electric source. Now, after you have subjected it to heat, you would soon find that you have calcium oxide, which is quicklime, CaO, plus CO2 gas, which is evolved. Now, let's talk about electrolytic decomposition. As we have already said, electrolytic decomposition is nothing but where you use electricity to break these bonds. Now, a classic example would be that of splitting water. Now remember, we haven't said breaking water, we have said splitting water. That means over here you have 2 electrodes. Each electrode would attract one kind of a charged particle towards itself. Now the reason that we use electrolytic decomposition for water is because, number one, water is a polar liquid, and hence it can easily rip apart into two different charges and move to the electrode corresponding to its charge. But why can we not use heat? Now, if you would like to use heat, the amount of heat required to break down water is equivalent to the sun being barely 15 feet away from you. Well, you cannot bear that, and to produce such amount of heat in the lab is nearly impossible. Hence, we resort to electrolytic decomposition. Now, let's start off with photolytic decomposition. Now, as we have discussed, photolytic decomposition is nothing but breaking down a substance using light. Now, a great example of this would be breaking down of silver chloride into silver and chlorine. Now, that is the reason you might have noticed in a lab that silver chloride is stored in a colored bottle which does not let light pass through. And this is also the same reason why you might have noticed when you go to a medical store that there are some medicines which are kept in bottles which would not let light pass through. So this is about decomposition reaction.
Let's consider a reaction where we have limestone, which is calcium carbonate, which when subjected to heat, which is thermal decomposition, you have the formation of quicklime, which is nothing but calcium oxide in its solid state and the evolution of carbon dioxide gas. Now, another example for thermal decomposition would be that of lead nitrate. When you heat lead nitrate, what you get is lead oxide plus NO2 gas and oxygen gas. Now, the example for photolytic decomposition is where you have AgCl, which is nothing but silver chloride, and you have the product as silver and chlorine. Now, one thing that you can note over here is that your AgCl, which is silver chloride, is silver in color, and the product is going to be grayish in color.